All right. Part A, prove that you can find the horizontal range using that scary function. So first, I just wrote down like the regular horizontal range function for like kinematics problems. And then I isolated for t like that, right? So x equals v cosine theta t, and then just t equals x over v cosine theta. And then you write the y function out. And that is this. Y equals v sine, that's an s, sine theta t minus 1/2 gt squared. And what you do is you replace this t with this t here. So you get that, right? Because, you know, t is just x over v cosine theta, so it becomes that. And then once you multiply all that out, you get this. So the reason this is tangent is because this is just sine over cosine, right? And then the v's cancel out. And then here, bring the 2 down to the bottom of the fraction, and then just distribute the squared to both sides of the fraction. So that is the y function for angle theta. Now we want the y function for the angle of alpha. So this is the incline, right? And so if we want the y function for like this, what's it called, incline here, right? Then we need to find the slope of this line, and that's just rise over run. In this case, the rise would be sine alpha because this is the opposite side of the angle, right? So sine alpha over the run, which is cosine alpha because this is adjacent to alpha. And so y equals mx plus b, m is the slope. In this case, the slope is tangent alpha because, again, sine over cosine. Right, so y is x tangent alpha. And now that we have both y functions in terms of x, we set them equal to each other. Like that, right? And then we want to get x on its own side, and so we divide both sides by x. And now that x is on one side, we just solve for x. All right. So I brought g over to the other side to make it positive right here. and then bring the tangent alpha over to the other side. So you get gx over 2v squared cosine squared theta equals tangent theta minus tangent alpha, and then multiply both sides. Excuse me. Multiply both sides by the 2v squared cosine squared theta. You get this. Divide both sides by g, and this is the correct formula for x. So that's part A. And then part B was asking for the range. Just calculate the range when alpha is 30, theta is 60, v is 50. So I just put it in my calculator. Oh. Okay, I don't know if you can see that, but just use those values, put it into a calculator, and the range is around around 147.28 meters right here. Part C was finding the distance up the incline. So you want to find the distance up this line right here, right? And then the general horizontal range would be the cosine value of the distance, right? Because again, x is cosine. X is the adjacent to this angle, and so x equals the distance times cosine alpha, because it's our angle, like this. And then you just isolate for d. Like that. Like that. And then after that, you use the x that we just found, the big function, and then plug it into the equation for d. Like this. And the reason I took this out was because we can actually use the trig identity, tangent equals sine over cosine, for both of these. And so you can rewrite that. You can rewrite it into this. And then after that, what you do is you cancel out one cosine theta here. And you get this. D equals 2v squared cosine theta times sine of theta minus alpha. Put another parentheses there. Over g cosine squared alpha. And now this up here, this can be converted into a more solvable form with a trig identity. 2 sine A times cosine B equals sine A plus B plus sine of A minus B. Like this. Like that. And then what we do is we just replace this, like 2 cosine theta times sine of theta minus alpha. Replace that with that in the form of this. So in this case, the A would be theta minus alpha, and then the B would just be theta, right? So 2 sine A cosine B, 2 sine theta minus alpha times cosine of alpha. And that equals sine alpha minus, theta minus alpha plus B, which is alpha, theta, plus sine of theta minus alpha minus B theta right here. So 2 sine theta minus alpha times cosine of theta equals sine of theta minus alpha plus sine of theta minus alpha minus another theta. And so when you simplify that, you get sine of 2 theta minus alpha plus sine of negative alpha, because these two thetas add up, and then these two thetas cancel each other out because this is just theta minus theta, and then there's a negative alpha inside here, so we just bring that out. We can just bring that out into sine 2 theta minus alpha minus sine alpha, like that. And then we plug that back into here, the D function in the numerator. So D equals V squared times sine 2 theta minus alpha, and then minus sine alpha, and then over G cosine squared alpha. Let me just check over. Yeah, like this. Right. And then let's see. From there, so from there, D is at its maximum when this is 1, because the bounds of the sine function is from -1 to 1. It can't go lower than -1, can't go higher than 1. And so obviously, if we want D to be maxed out, the sine function has to be 1, so we literally just replace this with 1. After you replace it with 1, it looks like this. Again, just replace this with 1. B squared is still there. And then from here, we need a way to get rid of this in order to get the function that we need. Well, this is perfect because there's an identity that says that this this is the identity, right? The identity is sine squared alpha plus cosine squared alpha. This is cosine squared alpha right here. And so we literally just subtract both sides by sine squared alpha and then replace that with this. Over G 1 minus sine squared alpha. Like that. Right. because this is the same thing as 1 minus sine squared alpha. And then from there, 1 minus sine squared alpha, that's a difference of squares. So we can change that into 1 plus sine alpha times 1 minus sine alpha, like this, right? So again, there's a difference of squares, so we can convert it into 1 plus sine alpha, ignore this, times 1 minus sine alpha, and then they cancel. Right, the 1 minus sine alpha is on the top and bottom, they cancel, and so after all that, we are just left with v squared over g times 1 plus sine alpha, like this, and this is the function that we want. And then, yeah, that's it. Thank you.